All right, now let's take a look at our parallel lines again and our perpendicular lines. And we're going to start here with their slopes. Parallel, perpendicular, slopes. Oh man. All right, so this is just a little bit of a review of slopes first before we dive into specifically parallel and perpendicular slopes. So the adventures of Slope Dude. So he's first going to go up the mountain and down, and then he's going to walk straight and then go down. So when he went up the mountain, he was going positive. So our slope is positive if our line is going that way. And when he was going down the mountain, negative. When he was just going straight, 0. And when he was falling, undefined. All right, also remember that our slope is just our rise over our run. So it is our change in y's over our change in x's. So our change in y's over our change in x's. And we can find the slope given 2 points based on the formula m, remember m means slope, of y2 minus y1 over x2 minus x1. And the 2 and the 1 of those, just to note which point you're pulling them from, make sure that 1 is 1 and 2 is 2. So like I said, change in y's over the change in x's. Oh man. All right. Let's look at this example. Let's plot these 2 points that form our first line. So we've got A at -5, 4, and B at 3, 2. So remember, when you're plotting points on our graph, you go X, Y. So our X for A is -5, 4. We go over -5, up 4. And that is where that point A is. Make sure on your notes when you're doing this to label this as point A. I did not do that on this presentation, but on your notes, to keep everything straight, label them. Okay, B is at 3, 2. And let's draw our line in between those 2 points. Now we can figure out the slope. If you're on a graph, then you can count the change in x's over the change in y's. So change in x's is 1, 2. Change in y's is 8. Is this negative, positive? Would slope man be going up, down, neutral, or falling down? He would be going down, so it is negative. Remember to reduce your fractions. Please reduce your fractions. 2 over 8 can be reduced. So our slope here is -1/4. Okay, now let's look more specifically at our parallel and perpendicular lines. Again, a review of that vocabulary. Parallel lines are 2 lines that do not intersect. And their slopes, when we're looking at their slopes specifically, they are going to be the exact same number. If slope on this first one is 2, the slope on the second one is 2. Okay, they're not parallel, they're not the same. And our perpendicular lines, they meet at right angles. We talked about this earlier, just reviewing it. So their slopes are going to be opposite reciprocals. What does that mean? Opposite means that their signs are going to be different. They're going to be opposite. One's going to be positive, one's going to be negative. If you look at our graph here, you can clearly see that one is positive and one is negative. So switch the signs. And reciprocal means we flip our fraction. Flip the fraction. Okay? So let's look at an example. What you're going to be asked is finding the slope and determining whether the 2 lines are parallel, perpendicular, or neither. So like I said, so we're going to plot these 2 points. We're going to plot these 4 points, 2 for each line, and figure out their slope and see if they are parallel, perpendicular, or they have no relation. So A is here, B is here, here's our line. C is here, D is here, here's our line. Okay, let's look at the slope of AB. Again, if I'm using a graph, then I can just count our change in y's over our change in x's. If you wanted to use those 2 points, then you can plug them into the formula. So when we do that, we already did that in the last example. If you caught that they were the same points, the slope was -1/4. Slope of CD also -1/4. So since our slopes are the exact same, they are parallel. Same slopes are parallel. All right, let's look at another example. Again, we're given our points of our lines. Want to plot them. E here, F here, and there's that line. G here, H here. There's our line. So another thing to point out is when we're plotting these points on graphs, just because they might look like they are parallel or look like they are perpendicular, we need to still compare their actual slopes because our pictures and our mind and looking at things may not come up with the right things, okay? So we need to still look at our slopes. Yeah, these look perpendicular to me, but it could be just slightly off, okay? So slope of EF is 3/2. Slope of slope of GH, sorry, is -2, 3. So looking at their slopes, are their slopes the same? Nope, so they're not parallel lines. We already kind of knew that. Are they opposite or reciprocal? Let's take the first part. Are they opposite? One's positive, one's negative? Yes. Are their fractions flipped? 3/2, 2/3? Yes. So their slopes are opposite reciprocals. That means we have some perpendicular lines here. Okay? So you're going to be asked to find the slopes of 2 lines and if they are parallel, perpendicular, or neither. So remember the qualities of each. You're going to mostly be doing this by putting them into the formula, where here I had put them on graphs. You can also graph them if you want to so that you can see them instead of just putting them into the formula. Let me know when you have questions.